Hi everyone, thanks for tuning in. My name is Agnieszka Słowik and I'm a third year PhD student at the University of Cambridge. I'm going to present the work on representation learning in emergent communication. Let's start with a quick summary so that you can see whether you are at all interested. In order to communicate, humans flatten complex, sometimes interconnected ideas into a single word or a sentence. We investigate a similar behavior in the artificial multi-agent setup. And in particular, we focus on the impact of the choice of the input representation and the corresponding representation learning method. We empirically show that agents parameterized by graph neural networks develop a more compositional language compared to the baselines of bag of words and sequence models, which, as we hypothesize, allows those graph parameterized agents to generalize better, in particular to new combinations of familiar data features. We hope our early results will probe research on emergent communication over complex hierarchical and relational data. What are referential games? In the standard setting, a referential game involves one speaker and one listener. The speaker has access to the input that the listener cannot directly observe. The speaker describes the input to the listener, and then the listener must choose the original input among the distractors based on the message from the speaker. It's a one-way communication, and importantly, the symbols have no predefined meaning. The meaning is emerging as the agents are trying to communicate effectively so that the listener can correctly identify the input object. Apart from using the standard data representations in emergent communication, which are bag of words and sequences, we also add corresponding tree representations in game one and graph representations in game two. The data is synthetic and randomly generated. Game one is inspired by the idea of learning properties, learning to communicate properties of an object. So, for example, describing its color and its shape. And game two is meant to represent communicating about arbitrary relational information, such as kinship relations between humans. We choose the standard graph convolutional architecture by Kipf and Welling with sampling based on a small exploration of graph architectures and their parameters. Our main experiments investigate the following questions. What is the effect of data representation and the corresponding representation learning models on the emerged language in terms of compositionality? What is the effect of structural biases on the ability to generalize to previously unseen combinations of familiar features? Let's say if the agents learn to discuss a red square and a blue ball, are they going to be able to understand a red ball? Can the listener identify the target if it receives a distorted message? So in this case, we hope the answer is no, because we would like those messages that appeared in the game to be as meaningful and as useful in solving the task as possible. We compare test accuracy and out-of-domain accuracy in game two, using an increasing number of distractors. As we observe, if we increase the number of distractors, I mean, of course, the game is becoming more difficult and the random baseline performance decreases. And in our empirical results, graphs are becoming more useful in out-of-domain generalization, especially when we have these plots with 19 or 49 distractors. Similarly, in topographic similarity, which is the correlation between the distances in the input space and the distances in the message space, we see that the value of topographic similarity, which is supposed to be a proxy for language compositionality, is higher for the graph representations, and especially in larger games of 29 and 49 distractors. This can be also seen when we analyze random samples of the input and message pairs. Finally, we test that the learned message is actually the one that most frequently leads to the listener or the receiver identifying the target object. Thank you very much for your attention. Please reach out to me if you have any questions or if you'd like to see the poster in more detail. I'm currently also working on emergent communication, so I'm happy to talk about this niche, albeit interesting field of research. You can find me on Twitter, SLOWIIKA, or send me an email. Thanks.